Hello, welcome to our presentation of MC Explorer, analyzing and visualizing motif clicks on large networks. First, we will briefly introduce some background, including labeled information networks, motif, and motif clicks. Then we will introduce our system's user interface and then system architecture. Finally, we will briefly sum up three medical applications of our system, followed by a real demo. In this presentation, we refer labeled information networks to information networks with labeled nodes. Large information networks with labeled nodes are prevalent in many applications, such as social networks, e-commerce networks, and biological networks. To extract insight from these rich information sources, we introduce our system, MC Explorer, which is an advanced analysis and visualization platform based on Motif and Motif-clique. To understand a Motif-clique, let's consider Figure 1, which shows a graph with nodes representing diseases in orange, drugs in green, and genes in blue. This graph contains a large number of instances following a pattern. A drug node is connected to a disease node through a gene node. In fact, this pattern, or motif, is a fundamental building block of Figure 1. A motif, which is also regarded as a higher-order connection pattern, reveals important information about a graph and has attracted a lot of attention in recent years. A motif-clique is essentially a complete subgraph of a graph G in terms of a motif. For example, in Figure 1, the subgraph S, enclosed by the red box, is a motif-clique for the motif shown in Figure 2. This motif is isomorphic to any subgraph of S that contains a drug, a gene, and a disease node. This figure shows the user interface of our system that runs on a biological dataset. A motif-clique font is displayed, which shows the properties of the node when the mouse hovers over it. On the right panel, a user can conduct a keyword search on the nodes and edges of the motif-clique font, or filter low-weighted edges for facilitating the viewing of the most important relationships. MC Explorer also includes functionalities of discovering motifs from the user-given graph based on state-of-the-art motif discovery system algorithms. A detailed introduction to the user interface will be covered in the demo. We now discuss the system architecture. MC Explorer adopts a browser-server model. The browser side provides an interface for user input, for example on graphs and motifs, as well as facilities for displaying the information about the graph and motif-clicks font. It also supports visualization and statistical analysis of the motif-clicks. The server side contains three major modules: motif discovery, motif-click search, and motif-click analysis. Details are to be covered in the demo. Motif discovery module allows a user to specify motif manually or find motifs automatically by pattern frequency or user-given label constraints. Motif-click search module is responsible for finding maximal motif-click. We adopt our recently developed algorithm called META, published on ICD 2019, which is a highly efficient and scalable algorithm for enumerating motif-clicks. Motif-click analysis module provides statistical analysis, including frequencies of motifs and motif-clicks, and node edge distribution of motif-clicks. Now let's take a quick look at three medical applications of our system. Details can be found in our paper. The first application is disease subtyping. The objective of it is to discover intrinsic characteristics of drugs and find subtypes of a given disease, for example, breast cancer. A better understanding of subtypes of a disease could help medical doctors to choose more precise medicine to treat patients. For example, on the left graph, we can see that the disease breast cancer is connected to a cluster of genes, which are connected to the drug marimoset. This implies that this could be one subtype of breast cancer. In fact, this motif-clique depicts a known subtype of breast cancer called sustaining proliferative signaling. Another application is drug mechanism investigation. We can use this system to discover unknown side effects of a particular drug. Take the motif-clique shown in the graph as an example. The ground truth is loxapine is used to treat schizophrenia. Based on this motif-clique, we can make a conjecture that obesity has a close relationship with loxapine. In fact, obesity is a side effect of loxapine. Therefore, Motif-cliques allows users to study medicine characteristics and find potential side effects of drugs. Drug repurposing has received a lot of attention from pharmaceutical companies because it is important to consider existing drugs for new therapeutic purposes. Take the motif-clique in the graph as an example. We know that loxapine is used to treat schizophrenia. Based on the motif-clique, we can make a conjecture that doxepin might be able to treat schizophrenia as well. To prove or disapprove it requires more knowledge and medical experiments, which is beyond this system. Finally, let's watch a 5-minute demo video.
Welcome to the demonstration of MC Explorer. It is a web application that enables motif suggestion, motif-clique discovery, and motif-clique analysis. To begin with, click on Step 1, Select Dataset. You can upload your own dataset or use a default dataset provided by the application like DrugBank. By clicking on Preview button, a random node is selected and displayed with its neighbors. Different colors represent different labels. Hover on the node to see the node's description and hover on the edge to see the edge weight. Right-click on any node for more functionalities. For example, add a node's neighbors to canvas. In addition, you can search multiple nodes by name on the side panel and change edge weight threshold or click on node properties to highlight nodes with this particular property. After selecting the dataset, you need to define a motif so that you can do a motif-clique search. Right-click on the canvas to add more nodes and edges. In this case study, let's design a motif with 3 nodes and 2 edges. Click Connect Gene and Disease, click Gene and Drug, with the hope that the gene can be a bridge to connect drugs and diseases, so that we can find underlying relationship between drugs and diseases. The application also provides 2 motif discovery tools. The first is to find a subgraph which is statistically more significant than other subgraphs, and the second one allows users to specify label constraints. In this case, the auto-discovered motif is the same as what we previously designed. Before searching, it is optional to set up custom configurations. Click on Set Config to open the configuration panel. You can give a limit on the number of results. You can give a lower bound for edge weights. You can force the results to include some certain nodes or exclude from other nodes. For example, let's require the results to contain breast cancer so that we can do research on it. You can let the application join the motif-cliques sharing the same node. You can give a range limit on the number of nodes for each type. For example, we are interested in subtypes of breast cancer. Then we require each motif-clique to contain exactly 1 drug and 1 disease. You can also sort the results by the number of nodes. Having selected the dataset, inputted a motif, and finished custom settings, you can send the search query to the server. The server starts motif-clique discovery and sends results back in a stream. Motif-cliques are displayed in a concentric layout. Nodes in the inner circle have larger degrees than nodes in the outer circle. The first motif clique is the same as what we present in the paper. This indicates one subtype of breast cancer. The right panel shows all node properties. We can click on the node property to highlight all nodes with this particular property. In this case, we can see all genes in this motif clique belong to the same gene family. Besides visualization of motif cliques, you can also inspect result statistics. Click on the Statistics button on the bottom to open the panel. You can see the whole graph contains 46,000 nodes and around 600,000 edges. Among the 100 motif cliques found so far, there are 1494 motifs and 1679 maximal cliques within them. You can also check the node distribution and edge distribution. The node distribution shows most motif cliques have fewer than 100 nodes, and the edge distribution shows that the most motif cliques have fewer than 200 edges. If you choose a larger graph dataset, the distributions here might shift to right. That's the end of the demo. Thank you for watching.